Hello everyone, welcome to the demonstration of OPAL-RT ePHASORSIM tool with an application of ETAP power plant controller. I, Nitin Chaudhary, working as a power system engineer at ETAP. Today we will cover the ETAP to ePHASORSIM export tool, also known as the DRT SIM tool. Next, we will cover the ETAP power plant controller, both software and the hardware. And finally, the controller hardware in the loop demo with the ETAP power plant controller hardware with ePHASORSIM solver running in the RT Lab hardware box. ETAP has introduced a tool to convert the electrical network to an Excel exported file which can be directly imported in the RT Lab ePHASORSIM solver using the DRT SIM tool. ETAP allows users to model, tune and test the controller logic inside the simulation environment, and once the user is satisfied with the results, they can directly deploy it to the real-time controller hardware, also known as the ETAP power plant controller. The exported Excel sheet can be directly being imported to the RT Lab ePHASORSIM solver. Now we'll be doing a controller hardware in a loop simulation between the ETAP power plant controller hardware box and the RT Lab ePHASORSIM hardware box. During the simulation or after the simulation, the results can be visualized using the Grafana dashboard which is being running inside the ETAP power plant controller. Also, ePHASORSIM allows user to visualize using the MATLAB or the Simulink scopes. Now let's move to the CHIEN live demo. Now we will be using example OPAL-RT to demonstrate the exporter tool. First, we go to the edit mode. From the DataX menu, we have an option to export to the OPAL-RT ePHASORSIM. This gonna open a conversion tool. Let's convert it. Once the conversion completes, it exports an Excel sheet that can directly import it to the ePHASOR solver. Let's take a look on the file. All the buses being modeled here. Each and every element of this net is being modeled to the ePHASORSIM Excel file. Example, the 2-winding transformer, 3-winding, machine data, and so on. Now let's design the power plant controller in this example. We can do this with the help of the controller element available inside the ETAP toolbar. In this specific example, we will be controlling the tie line flow of the utility to the set points which will be defined inside the controller page. For the active power control, we will be giving a reference set point of 1 megawatt that will be imported to the grid from the utility, and for the reactive power control, we are giving a reference of 0.5 megawatts. Let's run this simulation in the time domain load flow simulation. Okay, so here we got the results. So let's go to the end of the simulation. Now we can see that we have reduced the set points and the controller is doing its job. It's controlling the import from the utility to the given set points, and it's being compensated with the help of the WTG. Now this model is ready to be deployed to the real power plant controller box. Now we have prepared the ePHASORSIM model running in the RT Lab application. Let's go to the master block of this. In the master block, we have ePHASORSIM solver, which is the red box here. The exported Excel file from ETAP can be directly imported to this solver, and it is really helpful to solve the large networks very easily. We also have a DNP3 communication between ETAP power plant controller and the ePHASORSIM network running from the box. To deploy the ETAP power plant controller logic, we need to go to the ETAP controller website, and we can easily deploy from this website. Now let's execute the ePHASORSIM model in the real-time simulation. This will open a console window running the software in the real-time mode, and we can visualize the data during the runtime too with the help of the scopes. Now the controller is being communicating with the ePHASORSIM solution during runtime using the DNP3 protocol. As we can see, the tie line flow is around 2 megawatt. Now the controller will try to control the tie line flow to the set points which was defined in the ETAP control logic. Now it will compensate it and will make the tie line flow to be 1 megawatt and the reactive power to be 0.5 megawatts. and that will be compensated with the help of the WTG. Now we can see the controller has controlled the tie line flow of the utility to 1 megawatt and 0.5 megawatt, and that's being done with the help of the WTG. So the controller is doing its job. Now let's introduce a manual disturbance in the system. We will trip one of the motors inside the network. Now the controller should try to compensate the tie line flow back to the set points. Now the controller has again changed the utility tie line flow to the set points. This proves that the controller logic is working as expected in the controller hardware in the loop. For visualization, ETAP also provides a Grafana dashboard in which user can verify and plot the data during runtime and after the simulation too. Thank you.
Hello everyone. Thank you for attending this presentation on enhanced end-to-end real-time software in the loop, hardware in the loop workflows with ETAP and ePHASORSIM. My name is Etienne Leduc. I'm Energy Market Offering Manager at OpalRT. Today I'm going to be short and sweet. I'm going to present you our corporate overview. I'm going to discuss some areas of application. I'm going to present our partnership roadmap and the vision of the product that we'd like to bring to you, and finish with some joint offer benefits. So OpalRT was founded in 1997 in Montreal, Quebec, Canada. You can see our headquarters here to the right since the beginning. We have a strong international footprint with 20 plus subsidiaries, offices, and distributors. We have over 250 employees still with sustained growth. And we boast over 1,000 customers over the world, 50% of which are academic and research centers, and another 50% are industrial customers. First of all, I'd like to give you a quick overview of what is hardware in the loop in real-time simulation. So the real-time simulation is meant to connect to and test real hardware. And in order to achieve this, you need multiple things. So you need powerful hardware, you need a real-time optimized operating system, you need optimized and discrete models of power system and power electronic components. You need optimized solvers and compilers capable of parallelizing all calculations of all available processors. And you need industry-grade analog and digital I/O and communication protocols to exchange information with the hardware on the test. As you've seen in the great demonstration that was done by Nitin, you can design your power plant or any other type of power system in ETAP and export this network to an Excel file that can be used with our ePHASORSIM solver. That's a toolbox for phasor domain simulation embedded in the RTLab software that it allows you to simulate in real time on an OpalRT simulator platform to test your controller in the loop. Here, that would be the power plant controller. You can extend this idea also to cyber-physical simulations. So OpalRT provides, through a partnership with another company with a tool that's called Exada CPS, the capability to co-simulate the power system together with its communication network to get the best accuracy possible and closing the loop to evaluate the interactions between the communication network and the power system. So again, you can design your power system with ETAP, export it to the OpalRT system, and simulate this power system together with its communication network and the same box to limit the latency of the communication exchange. And then your signals could go out of the simulator to hardware on the test or to a SCADA system that could also be provided by ETAP. And what's also very great about this solution is that it allows you to emulate several types of cyber attacks, whether it be modification of packets, phishing, malware, Trojan. There are different types of cyber attacks that are available in this tool for you to test the response of your system and develop mitigation algorithm. So to go from ETAP to real-time with DRT Sim, it's been shown in the demo. It's quite simple. You design your model in ETAP. You connect your IO's communication protocols with C37118, Modbus, and so on. And it helps you reproduce poor grid conditions and anomalies to validate grid reliability in all its complexity and detail. So you can connect this to any type of controllers, whether it be in distributed generation, wide area monitoring, protection, and control, power system controls, or protection systems. All these different types of controller can be tested in real time with our simulators. So today, regarding our product roadmap and vision, so today you have the option in the DataX menu to export to ePHASORSIM. This generates an Excel file as it has been shown, and this is then brought to ePHASORSIM on our OpalRT platform. A next step that we'll be looking into this year is to migrate these scripts to our open source DB core. That's a new technology. So you can import through the API the ETAP data and then directly go to the ePHASORSIM solver through this database. And that can serve as a stepping stone for the next step, which will add a lot more value and would allow for converting the model to EMT data. So it could be used in other OpalRT solvers such as EHS that runs on FPGA for a small time step in the nanosecond range, or HyperSim or Artemis that are electromagnetic transient solvers that are CPU based. All of these being interconnected with the database and with the capability of database to translate model data between the EMT world and the phasor domain would allow users of ETAP to use different solvers depending on their current needs. So benefits you get from this is mostly about reducing the risk, cost, and time to market of grid automation solution deployment through thorough system validation using both software-in-the-loop and hardware-in-the-loop testing. Leveraging faster than real-time simulation with various available solvers in phasor domain and EMT domain. Leveraging also proven real-time performance for both extremely large power systems and extremely fast power electronic for inverter-based resources. Leveraging also the co-simulation capability between two grids, one in ETAP and one in Opal, or control in ETAP and a grid in Opal. Different configurations are possible. And even integrating black box control algorithm provided by manufacturers such as DLLs. That's also a capability that we bring. You can also reduce risk, cost, and time to market of grid automation solution deployment through augmenting test coverage, leveraging advanced test automation tools capable of automating thousands of what-if scenarios for off-hour testing, so you can focus on data analysis while at work and leave the automated testing work for you overnight. You can also leverage the capability to emulate destructive and other high-risk tests that cannot be executed in real life for obvious reasons. You can also reduce the maintenance effort of using multiple simulation tools through using a single source of truth centralized database, where, as I explained earlier, you can import from ETAP or from any other vendors to our database and then use this information in any type of solver or tool that we provide. Other benefits you would guess with us would be that we're a partner of choice in the real-time testing of automation and digitization. We can provide also operator training with real hardware in the loop. We can provide full turnkey solution with on-site integration, personalized project management and support, expert consulting services, flexibility and scalability in system size and complexity. Thank you very much for your attention. Again, I'm Etienne Leduc, Energy Market Offering Manager. If you have any questions, feel free to reach out to us. My contact information is here. Thank you and have a good rest of the day.